This video is for educational and informational purposes only. The content is based on personal experiences and is not medical advice. Always consult a qualified healthcare professional for personalized medical guidance.
They say cancer is a genetic disease. It's a very complicated disease. That's bullshit. I have the science. I publish these papers in top medical journals. If people want to live, they'll know about it.
Professor Thomas Seyfried is a world-renowned expert in cancer and a best-selling author of Cancer as a Metabolic Disease.
He has a revolutionary treatment for cancer that even your doctor doesn't know.
We have 1,700 people a day dying in the United States from cancer, and we have people dying from cancer in all countries around the world. Yeah, you can have cancer, but if you know how to manage it, it doesn't become a death sentence. Yeah, well, we had Pablo Kelly.
My name is Pablo Kelly, and when I was about 24, I was diagnosed with a grade 4 glioblastoma multiform brain tumor. I was given, 6 to 9 months talking to the oncologist. I declined standard of care.
With 2.5 years of metabolic therapy, voila, the tumor was operable. And the same thing can be with breast cancer, prostate cancer, colon cancer. They all can be managed quite effectively with metabolic therapy. The high-fat diet is designed to keep your mitochondria healthy. If your mitochondria remain healthy, you're not going to get cancer. It's not like, oh, let me go out and eat a tub of lard. Let the GKI, the glucose-ketone index, tell you what you can and cannot eat. And we know we kill cancer cells when we have a GKI 2.0 and below. Wait till the world knows about this. Everybody's going to be jumping on metabolic therapy. Where are you going? Well, they're learning. I can tell you right now, a lot of people know about it, but when they go to their professionals, even in Australia, I can tell you a lot of times, New Zealand, Australia, they get slapped down. They say, oh, there's no evidence to support. Wait, don't these people read? No, they don't read the scientific literature. And they either don't read it or don't understand it. They have to wait to be told. It's not like they have any ability to say, I want to do metabolic therapy. And then the system says, well, you can't do that. You must do standard of care. Oh, well, that prevents even the good physician that understands the science can't even do it. So the system has to be gutted. This system is not working for us. And who controls the system? The hospitals? The pharmaceutical companies? I don't know. You figure it out. All I know is people want to live, and the system is preventing them from doing that. And if those who live pay a price, your bones are a bone problem, bone density problems. You have emotional stress. You have cardiovascular problems. You have all kinds of new ailments for the fact that you survived toxic poison and radiation or surgical mutilation. The whole system has to be revamped and changed if people want to live and they want to get on with their lives. You can have cancer, but if you know how to manage it, it doesn't become a death sentence. You can take the fear and the anxiety out of this disease very easily. But that's not being conveyed. That information is not. I have the science. I publish these papers in top medical journals, and there it is, laid out in front of you. It's just, what am I going to do? Jam it down your throat? What do we do here? But if people want to live, they'll know about it. Oh, absolutely, prevent. You can't get cancer if your mitochondria are healthy. Don't forget our Paleolithic ancestors. Now, who wants to go back and live in a cave, right? You want to go back and, eat, what do you guys eat down there? Koala bears and kangaroos and that kind of stuff. You got a koala bear running through your backyard. Oh, he's dinner tonight. We then bring him in town, bring him on the streets of Sydney. Yeah. Wrestle them down. That's dinner for tonight, right? You think of the people that lived in Australia before the Irish came there and all these others. They were Aboriginal folks. What did they eat? How much cancer did those guys get? How much diabetes? How many morbidly obese Aboriginal folks did you ever see living in the outback and wherever? When you look at those kinds of folks, they were lean. They were chiseled. They had a lot of exercise. They weren't eating. Now you take those same folks and give them the great Western diet and lifestyle, and they got cancer, diabetes, obesity. They got all the stuff that the rest of us have. So it's clearly diet and lifestyle. And the gene mutations that people say, oh, I got BRCA1. We have a big paper ready to launch. Every one of those genetic risk factors are what we call a risk factor that initiates dysregulated cell growth because it impacts the mitochondria directly. So we know what causes cancer, and we can reduce the risk massively. But we have to change our diet and lifestyle. And some people would say, I'm going to roll the dice. It's like a guy who smokes. Oh, I like smoking. I don't know if I'll ever get lung cancer. I might get emphysema, but I like smoking. Okay, well, we're never going to take away pizzas and jelly donuts and all kinds of highly processed carbs from people. We just want to let them know that if you eat that, you put yourself at risk for cancer, diabetes, high blood pressure, hypertension, dementia, all these kinds of things. They just don't know that right now. But we offer a plan using the glucose-ketone index calculator as a tool to know whether or not you're in a zone of risk for cancer and chronic diseases, and what you can do to get out of that zone into a healthier zone, all quantitative, which then becomes everybody's personal choice to determine whether or not they want to live in a risky zone or a healthy zone. Yeah, and as they get worse and worse, they acidify the microenvironment, because their waste products are acid, and that causes a much greater amount of inflammation. So you have abnormal blood vessels, the immune system comes in, and the immune system then throws out growth factors and cytokines, which makes a bad situation much worse to this. And then, of course, when the cancer cells spread, which is called metastasis or metastasis, we have clearly shown what the biology of the metastatic cell is. An immune cell. It's a macrophage, part of our immune system itself. So we took us 10 years to figure this out, and the cancer field still thinks all cancer, these metastatic cells are stem cells. I can't go into the absurdity of how the cancer field looks at metastasis and looks at all this stuff. It's all based on silo gene think. And when you do that, you're lost. You're a lost soul. You're a lost scientist. We have clearly shown that these metastatic cells are hybrid cells of macrophages, which is a very powerful cell in our body to kill bacteria. And they're already programmed to move through lymph nodes. They're already programmed to enter and exit the bloodstream. And we already know that they're highly glutamine dependent. So we know how to kill them. At the same time, we know that the immune cells, the normal immune cells, need and use the same fuel as the tumor cell. So you can't be too aggressive in knowing, yes, we'll kill a lot of tumor cells, but if we don't use the tool correctly, we'll damage our own immune system, preventing our immune system from picking up the dead corpses from the metabolic therapy. So I guess the difficulty, which makes it a little bit more complicated and not as simple as I've made it. To me, it's remarkably simple. But we have to be sure that people know biology, and they need to know the difference between the biology of immune cell and the biology of a non-immune cell, and the biology of a cancer cell versus the biology of these different cells. So it's a biological problem, and it's how the cells get energy, what the biology of the cell is, and once you know that, this cancer problem becomes very manageable. Well, that's an essential fuel for cancer. You can't grow without it. The glutamine is given nitrogen, so the glucose gives the carbons, and the glutamine gives carbons and nitrogen, and both of them give energy, ATP. So the glutamine is you can't grow and make new DNA and RNA and proteins without a nitrogen source. So the glutamine provides the cancer cell with the nitrogen source. And the cancer is taking in glucose in large amounts. And those are the carbons for making fatty acids and nucleic acids. So there's a huge, powerful synergy between the carbons from glucose and the carbons and nitrogen from glutamine. Together, they are powerful synergistic fuels. But you can lower glucose with diet and lifestyle issues. But glutamine requires targeting. You can also lower some glutamine with great exercise. Exercise, which is another absolute necessity for managing cancer, is the exercise part. The exercise sucks the glucose out of the blood for the muscles, lowering blood sugar further, but also can lower glutamine. And then you come in with a small amount of glutamine targeting drugs, pulsing. That's why we developed the press pulse strategy. You can press glucose down, but you can't press glutamine because it's absolutely essential for our gut, our immune system, the urea cycles, and this kind of thing. So you really have to be strategic when you're targeting glutamine. You just can't chokehold glutamine because it's so essential for so many other things. So you pulse it. That's dosage, timing, and scheduling. You chokehold the glucose with the diet lifestyle, and you come in with parasite drugs and other drugs that will target the glutamine and the glucose together. And you exercise. You do a lot of exercise. I would say that most exercise, swimming, running, walking, depending on what age you are, you're not going to get a 90-year-old guy to run a marathon. But he can certainly walk around if he's still able to do that. Whereas younger people can be, doing more walking, weightlifting, and all this kind of stuff. Because the more activity you give your muscles, the more breathing you have, you make your mitochondria healthy. You're sucking the glucose and the glutamine out of the system, and then you come in with strategic targeting of these processes. And these cancer cells get hammered. They can't handle it. And then people say, oh, they're versatile. No, they're not versatile. We interrogated these damn cells. They are absolutely dependent on this fuel. And the reason why they look so hard, they look so great, because when you take radiation and toxic poisons, you free up the two fuels driving these cancer cells. So the fuels, what we're doing to the cancer patients are allowing the cells to have the very fuels they need to grow. So and that's why it's not effective for so many people. Yeah, you can keep these things at bay if you incinerate a whole region of your tissue with a radiation and poison somebody where they're vomiting and diarrhea, fatigue. I mean, this is causing stress on the tumor cell, but it's stress on the body too. Ketogenic metabolic therapy makes the normal cells in your body super healthy because you're burning ketones. You're not allowing them to be poisoned. But the tumor cells can't make those switches. They're locked into a fermentation metabolism. This is unbelievable. Wait till the world knows about this. Everybody's going to be jumping on metabolic therapy. Where are you going? The high-fat diet is designed to keep your mitochondria healthy. If your mitochondria remain healthy, you're not going to get cancer. It's just that simple. So you burn ketones, and it's not like, oh, let me go out and eat a tub of lard. Don't forget what our ancestors did. When they killed big animals, they would go for the marrow. The marrow had a lot of the bone marrow has fat in it. So they would get the fat and they would eat organ meat. Organ meat had a lot of glucose in it because the liver stores in glycogen. So we were getting all of our nutrients from organ meat and from bone marrow. Our ancestors knew what to do. What killed our ancestors, as I said before, was injuries and infections. They did not have antibiotics, and they didn't have orthopedic surgeons that could fix broken bones and heal flesh and this kind of stuff. So they died from infections and injuries. We don't die too much from infections and injuries today. Well, I should say there's MRSA in the hospitals, which is kind of a sepsis that can kill you real quick. But they're antibiotic resistant bacteria, of course, and that still will kill people, mostly in hospitals, if you can believe it. But we can manage some of these injuries and infections. But now we're dying from chronic diseases. We're dying from type 2 the complications of diabetes, cancer, hypertension, high blood pressure, cardiovascular disease. These are all conditions of energy abuse, mitochondrial disturbance. In some cases, in order to get cancer, not only do you have to damage and abuse the mitochondria, you have to do it in a cell that is capable of upregulating the fermentation machinery to replace the oxygen from respiration. Otherwise, you can't get cancer. And the evidence for that comes from neurons in the brain and cardiac myocytes in healthy people. They rarely, if ever, get cancer because neurons cannot switch to fermentation, nor can cardiac myocytes. They can't switch. So you never see cancer in these kinds of cells. Whereas other cells, liver cells, colon cells, breast cells, these all can be switched to fermentation. So but it's very clear when you know the biology of what's going on. Yeah, well, therapeutic ketosis is when your blood sugar is down and your ketones are up. And our ancestors, our Paleolithic ancestors, were always in a semi-state of nutritional ketosis. They did not have highly processed carbohydrates in the environment. They're eating kangaroos and wallabies and those kinds of things. right? Whatever they ate there in Australia, and we killed buffaloes, and wherever we were, we ate what was available for us. Well, you're not going to get type 2 diabetes eating buffalo meat, right? Because we have a hormone called cholecystokinin, which suppresses appetite when fats come into the environment. But when you eat sugars, you suppress cholecystokinin. You keep eating and eating. Glucose is an addictive molecule. It makes you hungry even when you're not hungry. So it makes you eat even when you know you're full. You eat a great big meal of buffalo meat, and then somebody comes out with a cheesecake, and you're going to eat the cheesecake too, right? I mean, this is all based on physiology. But our ancestors didn't have this. They were very active, so they had a lot of activity and hunter-gathering. I mean, you can only sit on your ass for so long before you have to go out and get something to eat. And to kill an animal and chop it up and butcher it and cook it takes a lot of energy. You have to collect water from the stream. You're always moving. You're always doing something. Otherwise, you're going to starve to death. And then when you ate as much as you possibly could, but it wasn't highly processed carbohydrates. And we probably slept better. We had a lot of exercise, and we were in a state of nutritional ketosis, not by choice, but by situation. And as soon as our technology came into place where we could cultivate grains during the Neolithic period, we could get more carbohydrates from rice, wheat, corn, these kinds of grains that brought more carbs into our diet. And then eventually we could process the carbs to make them more and more sweet and less nutritious. Of course, we get civilization around food sources. Otherwise, we'd all still be trying to kill kangaroos and buffaloes. But now we farm these things. We have farms for the animals, and we can provide the food for us. Now, today on the world, we have more obese people than we have starving people. Go figure this one out. So, and these obese people are mostly suffering from all kinds of chronic diseases. And cancer is being one of the big ones. So we're still biologically Paleolithic man. We're just in a totally different kind of environment than what we evolved to be in. And now our science and technology has evolved much faster than our biology. And as a result, we are morbidly obese. We're chronically diseased, cancer-ridden, dementia-ridden, and younger people are falling into the cancer and some of these chronic diseases, diabetes in little kids, cancer in little kids, young people. I've seen so many in the late 20s now, in the mid 30s, early 40s, cancer going on, colon cancer, breast cancer, brain cancer, bladder cancer. I said, what the hell is going on? It's all, and then of course we got all the microplastics and forever chemicals, and we know all of these will chronically damage mitochondria. So we know I know what pretty much is going on here, but we're tormented and tempted by advertisements on television and billboards with all these delicious foods. And we love them. Are you kidding me? I mean, you eat this stuff, I told you, when I eat, I get all excited, man. It's just like unbelievable. You eat a big pizza, Well, listen, I just let the GKI, the glucose-ketone index, tell you what you can and cannot eat. So each person should be their own experimental subject. So you take your list of foods, and your glucose-ketone index, which we published. It's a little meter now, Keto Mojo. You can go on Amazon, you can buy it. Everybody pricks their finger, gets a drop of blood, takes the glucose strip, and you get the glucose reading, and then you take the ketone strip and get the ketone reading. And then you'll be able to know what zone you're in, what glucose-ketone index zone. So the foods that you're going to list Australians might not respond the same way as a German or an Englishman or an Asian. So we don't know until that everybody measures their GKI and see what it does to their GKI. And we have this big thing now where you're in unhealthy zones, trial and error zones, and super healthy zones. And we know we kill cancer cells when we have a GKI 2.0 and below. So people say, well, I'm going to run out and get a 2.0. Oh, yeah? Let's see how easy it is. It's not easy. You can't eat any of those foods you're going to tell me. You have to do a lot of exercise. Oh, okay, give me one of the foods. Give me one of the foods. High fat meats. Well, again, that's probably not going to spike your glucose. Going to depends on how much you eat. Don't eat much of it. You get very healthy if you can just eat like some grams of it. Butter. Well, yeah, okay. Let's sit down and eat a kilo of butter. Right? It ain't going to happen. Of course, a little bit's not going to kill you. Right? None of this stuff is going to hurt you in small amounts. It's only when you start, you know, pounding down big amounts of this stuff. But yes, a big ribeye steak or a piece of liver, these kinds of things in small amounts. You throw some bacon on top of the liver, cook the bacon and liver together in the same. Uh, yeah, these are all pretty good as long as you don't overdo it. Now, then we have to have a big ass potato with a lot of bread. Okay, then we throw ourselves out of the glucose ketone. Yeah, but everybody likes that, right? Got to have a big piece of bread with butter lathered on the butter, and you dip it into the juices of the steak, the juices of the fatty steak. That throws you out. I mean, that's because the bread and the butter, I mean, we love it. It's very tasty. It's got full of carbs, very tasty. But if you ate the butter without the bread, it would be better than eating the bread with the butter. But also you can eat bread. But I mean, we love bread. I'm not going to stop eating bread. Prevention for sure. Once you have cancer, you can also manage it that way. But how many people are going to say, I'm not going to ever eat a pizza or a piece of bread with butter on it because I want to prevent cancer? Give me a break. It's just like the guy who smokes the cigarette. I'm not going to get lung cancer. I'll take the risk. Okay, some guy sitting there with a big, beautiful baked baguette, got a nice piece of butter on it. I said, oh, I don't know if I should do that. It might give me colon cancer. He's going to eat it. You kidding me? He's going to eat it.